notes and the video that were up on Friday. So this is page 9. So if you look at page 9, this activity is going to count for a quiz grade. You're going to have an opportunity as we look at this classifying solutions. You're going to be working on it today and tomorrow in class. So when we look at a system of equations and it says how many solutions, one possibility is that there is one, please write down one solution. One solution when you graph is that point of intersection. So one solution is the point x comma y where the two lines intersect. If, when we look at, so up to this point when we were graphing, that point of intersection, we will have no solution. So everyone should be writing this. We're going to have no solution when we have parallel lines. And it doesn't matter which way our parallel lines are, but whenever we have parallel lines, we will have no solution because there isn't a point of intersection. The last one that we are going to have is infinitely many. So infinitely many solutions is, a lot of these we saw when we put them in our Desmos calculator. And you can use that for part of this activity that we're working on, but infinitely many solutions is when you have the same line. So you have one line, and the other one is on top of that. So one line, the other line is right over the top of that line. So if you have a line drawn, you might have that line, and when you went to graph it, the other one. And that's because every point on both of these lines is a solution. So we say there's infinitely many. So there was a question in your homework a few days ago that said, is it possible to have more than one answer for a system of equations? Is there going to be more than one point of intersection? Yes, there could be every point on the line because there's infinitely many. They're the exact same line. So what you're going to be looking at today in class is I'm going to be giving you a sheet like this, and it's going to have these 6 different cards. So the 6 cards are labeled C1 to C6. What your final project is going to look like is something like this on this page in your notes. So on that bottom of page 9, you're going to put the graph C1, C2, C3, C4, C5. You'll put those on in that order, okay? So what you have to do is each card is going to have a graph, it's going to have an equation, and it's going to have a table. If it has a graph, can you tell it -2 on this graph? Can you tell what the y point is? Can you tell when x is -1 what the y point is? Can you tell when x is 0 what the y? So you can put those numbers in based on looking at the graph, right? From that, you might try and write your equation. Remember, when you write an equation, please write it like this: y equals mx plus b. So anytime you write an equation, and you'll have this page open when you're working with either by yourself or with your partner. So it says one of these 3 things is given, and you need to figure out the other one. So in this one, I gave you the equation, but the equation isn't in slope-intercept form, right? So I want you to look at that. If I was trying to find when x is 0, couldn't I simply go to this equation? So please write this right in your notes at the bottom there. And if I wanted to find when x is 0, I could change this and put 0 equals, or 0 plus, excuse me, 2y equals 8. And the next time I could try 1 plus 2y equals 8. In that first one, what do you have to do to solve that, to find what y equals? If I'm looking at it, Caitlin, what would we do? Divide both sides by 2.
And if I do that, I'm going to get my answer that goes right here. So this answer is going to be here. Here, I have to subtract 1 first, right? Can I now plot the point 0, 4, because this was a 4? Yeah, I'm going to go to 0, I'm going to put it in the point 4. So what you have to do is each card has to have the table filled in, has to have the equation, and has to have the graph. So after completing all 6 cards, then you will go to comparing each card and determining the system of the solution. You'll attach the 6 cards to the poster, you'll put them in this order, just like this. So an example of the completed project is here. Question, why?
So like if you have to like fix the equation, then if it was y, you have to divide it with x, which you have to subtract.
Right, so like in that one where I was showing you, like if I had x was 1 or x was 2, I'm going to substitute those in, and then I'm going to plot those on the graph, and I'm going to use my ruler and graph. So once I have filled in all of these cards, okay, so this is what it looks like. You have all of these 6 cards. You have to fill them all in. You can work with your partner on them, or you can work alone on this project. Then you are going to take these different things, and you are going to tell me the solution. So when I'm looking at yours, so I started mine. I've already filled in my graphs on them. But then what I'm going to do is I'm going to compare these 2 graphs and put them like next to each other and try and decide. You know what? If I compare these 2 graphs, should there be a point of intersection? Well, they're not parallel lines, C1 and C2, right? So they have to have a point of intersection. And then what you write on the bottom of the card is you tell me the X point and you tell me the Y point, okay? If we look at the 2 lines and they look like they're parallel, right? Do some of them look like they're parallel lines? Like if I look at C1 and I look at C3, just by looking at the picture that we have here, they kind of look almost exactly the same, like they have the same slope. So will these 2 lines, if I would intersect them, are they going to have a solution? Should be no solution. When I look at like these 2, should they have a solution? So you'll notice in these cards, no common solution, no common, infinitely many, and then there's a bunch that you're going to get that have solutions. So what I want you to do right now is to move with your partner.